Yo, so I've got like, I don't know, 20 minutes before I need to head to boxing. So we're going to try and see how quick we can do today's problem. Um, okay, special array with x elements greater than or equal to x, I guess. You're given an array nums of non negative integers. Nums is considered special if there exists a number x such that there are exactly x numbers that are greater than or equal to x. Notice that x does not have to be an element in nums. Okay, greater than or equal to return x if the array is special, otherwise return -1. It can be proven that nums is special. The value for x is unique. Exactly x numbers. So then, okay. I mean, literally, it is return all for I in nums if I is greater than or equal to x. Return x if all that else -1. That's literally it. X is not defined. Oh. What? Oh, if there exists a number such that there are exactly... Oh. Oh, interesting. Oh, okay. I thought x was something that was getting passed in. Ah, okay. So then... Oh, okay. Ooh, okay, interesting. That's a completely different problem. I thought x was getting passed in, so then you just check. But you could pass an x in to that thing that I just said. So then you can have a helper function here. Oh, and this isn't actually technically right either, because you would need to see if it is also equal to x in terms of exactly x numbers in nums. Okay, so this feels like, okay, that's a little different. So then, me trying to use NeoVim. Are there key bindings for editor? Yeah, let's go. Okay, sick. Okay, so then this feels like, yeah, we're not sure that nums is sorted. So then we need to sort it. Sort, and then binary search for index, and I'll elaborate on my thought process here in a second. So we sort it, binary search for index, and then given an array, if there exists a number x such that there are exactly x numbers in okay, search for index, yeah, and then diff of length to from end to index. Okay, so here's the thought. You get some, list of numbers 1, 5, 2, 3, 4. So then, does there exist a number? So then, let's say, so then x is 1. Then, is there exactly one element greater than or equal to x? So then, if we sort the list, we go 1, 2, 3, 4, 5. We find the index for 1, which would be 0. So then there's 5 elements that are greater than or equal to 5 elements that are greater than or equal to 1. So then we go 2, index, so index 2 here, or index 1. So we get index 1. Index 1, there are 3 elements to the right of that, so that's a no. We go 3, we get index 2 here, and so then we need to look at, are there 3 elements that are greater than or equal to? Yes. So then we would return 3. I believe that's it. I think that's about as simple as it gets. So then let's do this. Delete word, append sorted nums equals sorted nums, or sorted deep copy nums. If we want to do like a nice functional approach here, from copy import deep copy, and yeah, in terms of efficiency, that's inefficient, but we're doing it. So the sort's going to be of log in, and so then we sort the numbers, and then what is the binary search Python? There's some method, I cannot remember. What library is it? It's some built-in that has... Shoot, it's been too long. Bisect left, bisect Python. There we go. Yeah, so then bisect. Yes, okay. Let's see, that needs to be above that. From bisect, import bisect left as BL. And it might be, there's a possibility that I might actually need bisect. No, it would be bisect left, because in the case of 3, our example here, what we would want to see is we'd want to see where's the leftmost position that we would insert 3. So then we would look here, because we could insert 3 here or here. We want to know the left position, because then that's going to be 2. And then from there, we would just do len minus 2. So then sorted, so then len length equals len nums, and then what we would do is for I in range. Let's see, I think you'd only have to go up to half of the length, because at what point does it become untrue, right? So then okay, so then let's go back up here. So then the question is, when does search become untrue? Untrue. So if you're looking for x equals 1, that means that you list has to be okay, hold on. The length doesn't matter. Yeah, it does. So as soon as your number that you're searching for is bigger than the length of the list, it cannot have that many elements that are exactly equal to or greater than. So we would say for number in range, well, in range length, if length minus BL, let's see, is it A is the insertion point for X, so then we go iterable, okay, so then sorted nums number. If length minus BL sorted nums number equals number, return number, and then return minus 1. Okay, pretty sure this is a deal. So then we would, this one here, that, no, okay. Oh, bummer, okay. Okay, this is O of n, and then for the binaries, so then we've got the BL is O log n. So let's see here. If length, so then the length in this case is 5. If length, so then we go for number in range length 0. What? Yeah, what's the case with 0? Are there 0 numbers non-negative? Exists a number such that there are exactly, well, you could have 0, right? So 0 numbers that are greater than or equal to X. Oh, but they're all positive, so that doesn't matter. So then I suppose you can start at 1, or you probably should start at 1. Number in range 1 to length. Yeah, we're not actually indexing into the list here. So then we would go 1. Let's write this right here real quick. 1, 2, 3, 4, 5. So for number in range 1, so we'd look at 1. BL sorted nums number. So then the bisect left of this would give us 0. So then right here. So then the length is 5 minus 0 equals 5. Does that equal 1? No. 2. That would give us 1. So then 5 minus 1 is 4. No. 3. That would give us 2. So then 5 minus 2 is 3. If 5 minus 2, which is 3, equals 3, return 3. Yeah. Okay. Let's look at this one here. Let's give ourselves an opportunity to double check ourselves against these. So then 3 and 5. So it's len2. So for number in range 1 to length, which is 2. This is not inclusive. So we need to do plus 1, I believe. For number in range 1 to length. So then if length, which is 2, minus 1, or no, sorry, this is going to be 0, because So the number's 1. So it's going to get inserted at 0. So then 2 minus 0 equals 2. So that doesn't, or oh, sorry. Yeah. Equals 1. So then 2 minus 0 does not equal 1. So then you'd go to 2 if length, so then the length is 2. You'd still insert at 0. If length 2 minus 0 equals 2, return 2. There we go. Okay. I think we got it. Let's run that. Bang. Submit it. Bang. Let's go. And fast. Lovely.